And in this question, we will start to talk about how can we find the solution. Again, finding the solution is also similar what we did so far. Here you have a linear operator. You know that this is a linear operator, which means that whatever you put in here, it will take the fourth derivative minus 10 times second derivative plus 9 times y. So this is our differential equation. And in the A part, it says find LE to the RT. So what does it mean? Plugged in e to the RT for y. And that's why we are taking the first, second, third, and fourth derivative and plugged it inside this one. And once we do that, e to the RT is fourth derivative, second derivative, and itself. If you do this calculation and if you take the e to the RT out, factor out it, and you will get this equation. If that's 0, exponential cannot be 0, so this polynomial function should be 0, and you know that this is the characteristic equation. This is exactly what we have been doing. And if you can factor out r square minus 1, r square minus 9, these are the roots, and since e to the RT is the solution, what you need to do is just plug in 1, minus 1, 3, and minus 3 for r, and these are the 4 solutions. And for the B part, it says determine the 4 solutions of the differential equation. We did. These are the 4 solutions. Do you think they form a fundamental set of solution? And why? And what we are doing, we need to make sure that these are continuous. Actually, these are continuous everywhere. And we need to check if their Wronskian is 0. That's why I put all the solutions. We take the derivatives. Derivative of e to the t. Derivative of e to the minus t, it comes minus plus minus, and 3, it comes 3 factor in each derivative, and in this one again it will be 3 but plus minus is gonna be changing, and this is the Wronskian. We need to take the determinant of it. Check that out. To do that, we are if there is a common factor, you can take this factor out from the determinant. That's the property of matrices. That's why I am taking the e to the t out from there, e to the minus t out from there, e to the 3t, and e to the minus 3t for each column. The common factor, I am taking it out. And if you multiply this, you can see that this is going to be just 1. And if I take the e to the t out, this is going to be 1, 1, 1, 1, 1 minus 1, 1 minus 1, 1, 3, 9, 27, 1 minus 3, 9, minus 27. Exactly this is what we are getting. And from here, to be able to get the determinant, we can do the row operation, and we need to make this part 0. Remember that we have been doing in linear algebra. So to make this one 0, you are multiplying the first row by minus 1, adding to the second, and you need to do all these row operations in here, and this is what you will get at the end. Make sure that you are doing that, because you will be doing that in the exam. And here, since this is a triangular matrix, the determinant will be just the multiplication of these diagonal elements, and since this is 768, this is not 0, so they form a fundamental set of solution, and the fundamental set of solution will be the linear combination of these 4 solutions.